So, good morning, all of you. Today we discuss the multiplexer, that is one of the application of your combinational logic design. It is a combinational circuit used to select a binary information from one of more input lines and direct it to the output line. So this is what from one of many input lines and direct it to the output line, as word itself shows that the multiplexer. So multi-input, we are having with the multi-input and single output. We will get the single output from this. It is also called as a data selector. It is also called as a data selector. So and it is also called as what it is called as a switching circuit also in this case. So here the block diagram, we'll discuss that block diagram, that multiplexer, we'll discuss that part, all this. So multiplexer adds, if you see here, the two data inputs we are having with these two data inputs and one output line, this data input line and one output line, and this is what one of the switch, or this is select line. Yes, this is what your S0 is what select line. So two input line and one select line and this one output line. As we people know that you're in a combinational logic, our output line or output, it totally depends upon your input line. Yes, your output is totally depends on your input. So here in this case, that multiplexer, your output is based on your, or it depends on your select line. We'll discuss that one. So this is your multiplexer. We can say that this is your 2:1 multiplexer. This is your 2:1 multiplexer having two input line and one output line. So truth table shows that this truth table, with this truth table as input, as we will know that S0 as input and your Y as your output, your Y as your output. So as S0, if you think about this S0 as binary number 0 and 1, so S0 as a select line is select as 0. If select the 0, then we get the which select line get activated, or this data line is activated. We can say that from this S0, that is D0. So here S0 is 0. When S0 is 0, Y output we got some, that is D0. Is it? Next, when S0 is 1, then D1. S0 is 1, then D1 output we got. So S0 is 0, then D0, and when is S0 is 1, that is D1 we got. That is the truth table, and from this Y, that is output, we'll get the D0 and D1 as 0 and 1. So we will discuss the after this, that is logic diagram of this truth table. Before going to this logic diagram, we'll with the help of function, that is Y output function, we'll draw the logic diagram. So before that, we have to find out the output function, that is Y. So here that function Y is equals to, so here that Y is equals to S0 is 0 as in a SOP, that is S0. So here S0 bar D0. So Y, here we can say that S0 bar D0 plus here S0 is 1, so S0 D1. So here S0 D dot D. Okay, so here the that boolean function we are having with. Next, by using this boolean function or this output, what we can say that function, we have to just draw the logic diagram. We have to just draw the logic diagram or logic circuit, we can say that. So you have to just draw the logic diagram for this. So this is our 2:1 multiplexer. Again, let me tell you here, before going to this logic diagram, again this one of the students having the difficulty, like how we can select this for 2:1. We have to select the single select line, or we have to use the what we can say that how many select line we have to do. It is because this is the multiplexer, and in this multiplexer, if you say that here that n, as n is equals to, here we will know that 2 raised to power n, yes, 2 raised to power n. So here basically that m here, n is equals to m, that is log to the base 2. Here we can say that m is equals to log to the base 2 n. Yes. So here number of input lines. So here number of input line, we can say that log to the base 2. If you select the log to the base 2 and the number as n is equals to, if you select the n is equals to, if you select the n is equals to 2, that is the number of input line, or the that is 2 is to 1 to select for this 2 is to 1, so 2 data set. So here n is equals to 2, so that is what 2. Here as we will know that as log a, log to the base a, and a is 1. So here as 1, the value is going to be 1. So number of select lines, here we can say that number of select line is going to be 1. Number of select line is going to be 1. We'll discuss that part in a 4 is to 1 multi. If you take the example that is n is equals to 4, we'll discuss after this, that is 4 is to 1 multiplexer, that is 4 is to 1 multiplexer. So n is equals to 4, so here again m log to the base 2 n. So here log 2 and n, that is 2 square. So here 2 log base 2. So here again the value is going to be 1, and 2 into 1. So here the value is number of select line is for 4 is to 1 marks, that is 2. So number of select line is 2, that we'll discuss. Okay, so we will discuss that. Okay. So logic diagram, from this function, that logic diagram as input line or the data lines that D0, D1 and S0 is your select line with S0 bar, so that is complement. So we have to just draw the 4 lines for this. First is for D0, that is you just draw the D0 line. Next for your D1. Next for your S0, that is select line, and here that is S0 bar. So the first, if you want to draw that logic diagram, here D0. So data line here, that is D0, is basically that data input line. So from this we have to take the one line from this data line, that is D0. Another is what your S0 bar. So this is basically your S0 bar. Yes. So from this we have to just take that one of the line, that is S0 bar, from to AND gate, to apply to AND gate. Next is what your S0 and D1. So another line is what, that is S0 and D1. Okay, so this is what another input line. So here that we have to apply for to the OR gate. That is OR gate, here that output as a Y function. So here this value for this AND gate here, that is S0 bar D0, and here that is S0 D1. We'll get the value here S0, that value is S0 bar D0 plus S0 D1. In this way we can say that we have to just discuss here, that is from block diagram to logic diagram, that is 2:1 mux, that is multiplex. Okay. Next we'll discuss the 4:1 multiplex. Okay. So next is what your 4:1 multiplex. It is commonly called as your mux. It is commonly called as mux. So that 4:1 multiplexer, again we'll discuss the block diagram of this 4:1 multiplexer. First we'll discuss the block diagram of this 4:1 multiplexer. Four is to 1 multiplexer. So here that is D0. You can say that D0, D1, D2, and here D3, and here one output, that is Y. As we discussed that already, we discussed the number of input or number of select line. So here that 2 select line, we discussed the 2 select line for this 4:1, and how it should be, we'll already discussed that S0 and S1. Okay, S0 and S1. So here that block diagram shows that the 4:1 mux D0, D1, D2, D3, and here the 2 select line and 1 output. Okay, so here that truth table, here the truth table of this, we'll discuss the truth table of this 4:1 multiplexer. That already we discussed that truth output of this multiplexer, in this multiplexer, that output is dependent on your select line. So select line S0 and S1. So we have to just consider that select line as input S0, one of the, this is what your S1, and the output S0, S1, and the output. Okay. So here S0, S1, and your output, that is Y. So that number of input for this S0 and S1, that is 0, 0. Next what your 0, 1. Next is what your 1, 0, and 1, 1. Okay. So here that select line is when 0, 0, 0, 1. This is our standard truth table for this binary input, that is 1, 0, and 1, 1. So next is what your S0 and S1. When S0 and S1 is 0, 0. When S0 and S1 is 0, 0, then D0 is to be selected. Then D0 is to be selected, that is, so here in this case that D0 is to be selected, and you will get the output as Y is equals to your D0. Okay. Next, when we can say that you are saying that S0 and S1, that is 0 and 1. So here D1 is to be selected. So here the term is D1, and same as 1, 0. So D2, and for 1, 1 it is going to be your D3. So it is what D2 and D3. Okay. So in this way, the truth table as S0, S1, and Y. So here we get the output in this way. Okay. So next is your function, that is output function, but we can say that here that y is equals to, get the output y for this S0 and S1. You can see here S0 and S1. So here S0 and S1 both are that complement, that is 0 as SOV form. You will know that S0 and S1, that is 0 0, that is S0 bar, S1 bar for this output y and D0. So here y already I discussed, that is S0 bar, S1 bar, that is D0, plus here that 0 and 1, so it is going to be your S0 bar, S1 D1, plus here S0 S1 bar D2, S0 S1 bar D2, plus your S0 S1 D3, S0 S1 D3. Okay, so this is what your function for this 4:1 multiplex. Next we'll discuss that logic diagram of the same, that is logic diagram. Okay, so here that logic diagram shows that the logic diagram for this 4:1 multiplexer, again based on your what boolean function or this output function, you can say that. So here if you observe that S0 bar, S1 bar, S0 bar, S1, S0, S1 bar, S0, S1. So here for this S0, S1, these both are inverted, that is complemented term, and the output, that data lines, is what D0, D1 and D2 and D3. So for this input lines, for this input line must be your D0, next is what your D1, next is what your D2, D3, S0, that is invert S0 bar, S1 and S1 bar. Okay, so here that is S0 bar, S1, first term is what your S0 bar, S1 bar and D0. So first we have to just draw for this S0 bar, next what your S1 bar and D0. Okay, so it applied to your multi-level AND gate, one of the input, that is multi-level AND gate, that is what we can say that one of the AND gate. Next second term S0 bar, S1 and D1. So here that S0 bar, S1 and D1 applied to another AND gate. Next here S0 bar, S1 and here what we can say that S0 bar, S1 and D. Okay, next S0 S1 bar and D2. So another that is data input line, that is D2 is what AND gate applied to. Next is what S0 S1 and D3. So here that is S0 S1 and your another data line, that is D3. So here you are having the, and we have to just apply to this one of the OR gate, that is one of the OR gate, and the output is what, Y. Okay, and this output, basically this is your output, is what S0 bar, S1 bar, D0 plus S0 bar, S1, D1 for this. Next what S0 S1 bar, D2 and S0 S1, D3. So in this way we can draw the logic diagram for 4:1 multiplexer. Okay, Next, that is 8:1 multiplexer, we'll discuss in our next lecture. Thank you.